Today we're delving into Unit 3.1 of the first half of General Chemistry, which covers chemical equations. If you find value in this video, please like it and let people know about the channel because it really does help. Chemical equations are important in chemistry because they provide a concise way to represent chemical reactions. A chemical equation shows the reactants, the starting materials, on the left-hand side, and the products, the substances produced by the reaction, on the right-hand side, with an arrow indicating the direction of the reaction. Chemical equations allow chemists to describe and communicate the details of a chemical reaction in a clear and standardized way. They also help chemists to balance the equation, which ensures that the same number of each type of atom is present on both sides of the equation. Balancing chemical equations is important because it allows us to accurately calculate the amount of reactants and products needed for a reaction, and to predict how much of a product will be formed given a certain amount of reactant. Balancing a chemical equation in chemistry involves adjusting the coefficients, numbers in front of the chemical formulas, of the reactants and products so that the same number of each type of atom is present on both sides of the equation. Here are the general steps to balance a chemical equation. 1. Write the unbalanced equation. Start by writing the chemical equation with the correct chemical formulas for the reactants and products. 2. Count the number of atoms. Count the number of atoms of each element on both sides of the equation. 3. Add coefficients. Place coefficients in front of the chemical formulas to balance the number of atoms of each element on both sides of the equation. 4. Check the balance. Make sure that the number of atoms of each element is the same on both sides of the equation. Reduce coefficients to smallest whole number ratio. If any coefficients are fractions, multiply all coefficients by the denominator to get rid of the fraction and make them whole numbers. 6. Verify the balance. Double-check that the equation is balanced by counting the number of atoms of each element again. Here's an example of how to balance the chemical equation for the combustion of methane. CH4 plus O2, CO2 plus H2O1. Write the unbalanced equation. CH4 plus O2, CO2 plus H2O. 2. Count the number of atoms. On the left side, there is 1 carbon atom, 4 hydrogen atoms, and 2 oxygen atoms. On the right side, there is 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. 3. Add coefficients. To balance the equation, we need to add coefficients to the reactants and/or products. Let's start with hydrogen. We need 4 hydrogen atoms on the right side to match the 4 on the left side, so we'll add a coefficient of 2 in front of H2O to get A, CH4 plus O2, CO plus 2H2O. Now we have 4 hydrogen atoms on both sides, but the oxygens are still unbalanced with 2 on the left and 3 on the right. To balance the oxygen, we'll add a coefficient of 2 in front of O2 to get CH4 plus 2O2, CO2 plus 2H2O part 4. Check the balance. We now have 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms on both sides of the equation, so it's balanced. Reduce coefficients to the smallest whole number ratio. In this case, all the coefficients are already the smallest whole numbers. There's a 1 in front of the CH4 and CO2. 6. Verify the balance. We count the number of atoms again to ensure that the equation is fully balanced. CH4 plus 2O2, CO2 plus 2H2O. On the left side, 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. On the right side, 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. The equation is now balanced and shows that 1 molecule of methane reacts with 2 molecules of oxygen to produce 1 molecule of carbon dioxide and 2 molecules of water. It may take some trial and error to balance the equation, but with practice, you'll become more proficient at it. Balancing chemical equations is an essential skill in chemistry because it allows chemists to predict the outcome of chemical reactions and calculate stoichiometry, the quantitative relationship between the reactants and products of a chemical reaction. Chemical equations also provide insight into the underlying chemical processes that occur during a reaction, allowing chemists to understand the mechanisms of chemical reactions and to design new reactions for specific purposes. Overall, chemical equations are a fundamental tool in chemistry that allows us to study and understand the behavior of matter and energy at a molecular level. Based on what you learned, think about the following question. What are the balanced equations for the following reactions? 1. Combustion of propane, C3H8 plus O2, CO2 plus H2O. 2. Formation of rust, FeCl2 H2O Fe820.3. Acid-base neutralization reaction, HNaOH NaCl H2O 4. Decomposition of hydrogen peroxide, H2O2 H2O plus O2. Double displacement reaction, NaCl's PbNO32 NaNO3 PbCl2.
Thank you so much for spending your valuable time learning and bettering yourself. If you like the video and want to learn more, donate, or get tutoring, please check out my website, nocollegeneeded.org. You can use the code NCN for 20% off tutoring and any supplemental material.